are the solutions for test 16 for algebra. We'll take a look at our first problem here. And here we are adding polynomials. And so when we do that, we look for like terms. And so I'm going to line up the terms that I can combine together. So like, for instance, the 3x squared and the 4x squared are going to combine together. The minus x and the minus 2x will combine together. The positive 6 and the negative 9 will combine together. So I'm just adding them up, and when I add, I just count up how many x squareds I have. I combine the two coefficients. 3 and 4 make 7x squared. Then I have negative 1x, negative 2x make a negative 3x. And then I have 6 and negative 9 make minus 3. And there is our answer. Taking a look at our next problem, we have to subtract. And so whenever I subtract, I'm going to change this to an addition problem. Now when I do that, all the signs are going to switch inside the second set of parentheses. And so I add the opposite, and then I'll go ahead and rewrite the terms I can collect. So I've got the negative 5x to the third, and the positive 6x, and the minus 9. And so I can collect the terms that have the same variables raised to the same powers. So 2x to the third minus 5x to the third makes negative 3x to the third. And then I have negative 5x plus 6x makes a positive 1x. And then I have negative 9, negative 8 add together to make negative 17. And that is our answer. Looking at the next one, it says the angle ABC, so angle A, B to C. So this large angle here is, and then it's this expression right here, this polynomial. Write the polynomial that represents ABD, so this missing side right here. Well, we have DBC, so let's subtract this from ABC. So let's go ahead and do that. So it's going to be set up this way: 15x squared minus 2x minus 11, and we're going to subtract the 7x squared minus 14. So I'll put this in parentheses so you can see it as a polynomial, and I'm subtracting, so I'm going to end up adding the opposite. So I'm going to add the opposite of these signs and then collect the terms. And so now I've got an 8x squared, nothing to combine with that 2x, so I'll bring that down, and I subtract these terms since they're opposite in sign. That gives me a positive 3. And this is my polynomial, and we're dealing with an angle, so I'll put a degree sign in the upper right-hand corner. Let's take a look at the next three problems. Here we are multiplying a monomial over this polynomial. So it's going to be negative 8x to the third multiplied by 7x squared. And then we're going to multiply, and then we'll add on that negative 8x to the third multiplied by a negative 3x. And then I'll add on the next one, so negative 8x to the third multiplied by the negative 2. So when I do that, I multiply the coefficients. So I get negative 56, and then add up the exponents, x to the fifth. Next term is just a positive 24x to the fourth, positive because the two negative signs. And the last term there is going to be a positive 16x to the third power. So let's take a look at the next problem. Here it says to factor. So when we factor, we're looking for common factors from each of the terms. So I see that 2 goes into each of these coefficients. I also see that there's at least one x in each of the terms. So I'm going to pull out an x as well. So I'll put the 2x on the outside of a parenthesis, do the division, and I'm left with a 7x squared minus x and a plus 4. That's the factored form. So if you end up factoring and you see common factors inside the set of parentheses, then you can take out that extra factor at the end. And on this one, we're multiplying binomials, so we use the FOIL method, the first, outer, inner, and last terms. Our first terms are 4x times by 2x. So these are our first terms right here. And then we end up with an 8x squared. Common mistake is people forget to change the exponents here when we're multiplying, so watch for that. And then the outside terms are 4x and 5. So 4x times by 5, and that makes 20x. And then the inside terms are right here. Negative 3 multiplied by 2x gives me a minus 6x. And then the last terms right here are going to going to be negative 3 multiplied by 5, so it makes a minus 15. So I collect these two terms, and I'm left with 8x squared plus 14x minus 15. And then the next one I have here is my area problem and a perimeter problem. So I'm going to break this into two different shapes. So there's two ways to do the area. You can either make a large rectangle and subtract this section, or you break it into two rectangles and just add them. And I'm going to choose to do that. So on my area, I've got this length is going to end up being negative 4x and negative 3x. So it makes negative 7x for this length right here. And then this side right here, I'll need that for the perimeter later on, is going to be negative 4x plus 5 plus negative 3x. So that's where I'm getting negative 7x plus 5. So now I have all the sides, so I can find the perimeter, all 7 sides here. And let's see, 1, 2, 3, 4, 5, 6 sides actually. And then I will find the area by multiplying the base times the height. So I'll go ahead and write it this way. I'll show my rectangle. And this side right here was negative 4x plus 5. This side was negative 7x. And so I go ahead and multiply negative 7x multiplied by negative 4x plus 5. So when I do that work, I get a 28x squared minus 35x. And so now I'll do the next one. So I'm going to add on this smaller one, which is just a perfect square, negative 3x and negative 3x. So that makes a negative 3x squared. And so it's going to make a positive 9x squared. So I go ahead and collect these two terms. That makes 37x squared minus 35x. And since this is area, I'm going to write down units squared. So that's the area. Now we still have to find the perimeter. And so when we do that, I've just got to add up all these sides. So I'll start with this side right here. So for the perimeter, and again, this was the area here. The perimeter, I'm going to take the negative 4x, and what I'll do is I'm just going to bring all of the x terms together. So I've got another negative 4x, a negative 3x, and negative 3x. So I've got two negative 4x's, so I'm going to double that. And then I've got two negative 3x's, so I'll double that one. And then notice here, I've got a negative 7x and another negative 7x. So I'm going to double, add together here, but double negative 7x. And so after that, I'm going to go ahead and do that work, and then I'll add up all these two 5s in just a moment. So again, I've got the 5 plus 5, I guess I could write down. And when I do this, I've got negative 8x, I've got a negative 6x, and I've got a negative 14x, and then plus the 10. And so I'll collect these two terms, and that makes negative 14x minus 14x plus 10. And together that makes a negative 28x plus 10. And these are units. Don't know what the units are, so I'll just write units. And this is the perimeter. So let's take a look at our next problem. Here it's an area problem. We're supposed to find the shaded region here. So what we have is a square. Now, I know it's a square because see, it's touching, the circle's touching each of the sides. Looks like the length is 10z. It's not xz, but 10z. Let's fix that. So we'll write down 10z. So 10z. And we're going to subtract the circle. And the circle has a radius, and I'm going to cut that diameter in half, 5z. So I divided the 10 by 2 to get that number. So I'm going to do base times height here. So 10z squared minus pi times by 5z squared. And so I do some more work. This makes 100z squared minus pi times by 25z squared. So I'll go ahead and just factor out the 25z squared, and that leaves me with 4 minus pi. And this would be units squared. So I write it in the factor form because it's a little bit easier to do that work. See, all I have to do is square z1s, multiply by 25, and then just multiply it by the difference of 4 and pi. So looking at this one, we want to find the surface area, and we're going to simplify the answer. And so we're going to go ahead and look to see what a cylinder looks like if we go ahead and pull it apart. So we'll end up with two circles and a rectangle. And this lateral surface that goes between the two circles is the rectangle. This height is the x plus 7, and this distance goes around the circle. It's the diameter times pi. It's the circumference. And over here we just have the radius for the circle. So what we have are two circles. So two circles. And so it's going to be pi r squared times by 2 plus a rectangle. And that rectangle is just going to end up being diameter. Now diameter is the same thing as 2r. So that diameter right there is 2r. And so 2r pi times by the height. And so when I go ahead and look at this, I've got a common factor. I've got 2 pi r. I'm going to pull that outside, and that leaves me with r plus h. And see, this is what I'm going to use to go ahead and substitute the numbers into the formula. So 2 times pi times r, which is x plus 4. And then I need to multiply that by the sum of x plus 4 and x plus 7, because x plus 7 is the height, x plus 4 is the radius. So I'll double this x plus 4, and so I'm left still with pi, times by 2x plus 8. And over on this side I get 2x plus 11. So I go ahead and multiply out using the FOIL method. So I still have this pi, and it's being multiplied by 4x squared plus 22x plus 16x plus 88. So I just use the FOIL method. First, outer, inner, and last. So I'll collect these two terms right here. So I still have this pi. Got 4x squared plus, this makes 38x plus 88. So now I'll go ahead and multiply by pi. It leaves me with 4 pi x squared plus 38 pi x plus 88. And that's the polynomial that represents the area. So it's going to be units squared. And so there's our answer. So these are the problems that you're going to see on the test. Good luck.